Hello students, welcome back to next unit. We are going to start unit number 2 in today's session. This is the unit name is vapor compression refrigeration system. It is unit 2. The first thing is I am going to introduce vapor compression cycle in this session, and we are going to see the rest of the topics in subsequent sessions. So these are the content in unit 2. We have 10 hours. We are going to deal this unit in 10 hours. The first topic is vapor compression cycle, and I am going to introduce two types of diagrams: pH diagram, that is pressure enthalpy diagram, and we have TS diagram, temperature entropy diagram, and deviations from theoretical cycle that we are going to discuss in second session, and then subcooling and superheating, and the effect of subcooling and superheating on compression cycle, vapor compression cycle, we are going to discuss here, and the effects of condenser and evaporator pressure on COP, and then multi-pressure system, low temperature refrigeration, cascade systems, and then we are going to discuss problems, and we are going to see the equipment types. There are compressors and their types, condensers and their types, and expansion devices and their types, and last evaporators and their types. So I have divided this entire unit into 10 sessions, and today we are going to complete the first session on vapor compression cycle, and I may take more time on problems. While doing problems, at least it may take 2 sessions. I may take one extra session on problem students. So this is the plan for our second unit. We are going to see the vapor compression cycle here. Vapor compression refrigeration system. A vapor compression refrigeration system is an improved form of air refrigeration system, and the first one we have seen air refrigeration system in last unit, and this is the next development in refrigeration systems, that is vapor compression refrigeration system. It uses a working substance called refrigerant. Refrigerants we have seen in last unit, that is the last topic in last unit, where different refrigerants we have discussed, and their advantages, disadvantages also we have seen, and its nomenclature, classification of refrigerants we have discussed in the earlier unit itself. Which condenses and evaporates. So here refrigerant condenses and then evaporates at temperatures and pressures close to atmospheric conditions. Common refrigerants used include ammonia, that is NH3, carbon dioxide CO2, sulfur dioxide SO2. So these are the three common types of refrigerants used in vapor compression refrigeration system. The first vapor compression system was developed in the year 1834, and almost 100 years back, by Jacob Perkins using hand operation. So for compression, everything he has done using hand operation. Working principle: the low pressure refrigerant is compressed into a high pressure area refrigerant using a compressor. So that is the first compression process, as we discussed in earlier topic also. First compression takes place. So here we are compressing the refrigerant. In last unit we have compressed the air, whereas here we are compressing the refrigerant. This process is termed vapor compression refrigeration system. The refrigerant absorbs and releases latent heat while circulating in a closed loop system. So this is the working principle of vapor compression system. Whereas this latent heat is nothing but the heat in the heat energy within the substance that may be either absorbed or released from the substance in terms of heat energy. So that is known as latent heat. So vapor compression cycle, there are four cycles, four processes, as we did in earlier type also. Compression, that is the first process. High pressure vapor is formed. Condensation, heat is released and the refrigerant turns into liquid. So that is the condensation process. And expansion, the pressure drops. Evaporation, heat is absorbed and the refrigerant turns into vapor again. So this is a cyclic process. So first step is, that is, first process is compression, and then condensation, expansion, evaporation. These are the four processes and happening in cyclic manner. Applications: industrial refrigeration system, air conditioning system, cold storage rooms, and domestic refrigerators. So this is a simple diagram. You can see here, these are the four processes happening. So this is the compression. Compression here, it is happening through the compressor that is driven by a prime mover. It may be an engine or motor or some other device, and we have a compressor, and then the compression process. Then it is followed by condensation process. Condensation process. So this is the condenser. Here heat is removed. Heat is removed. So during compression process, the refrigerant acquires two properties, that is high pressure and high temperature. So we have to retain the high pressure as well as we have to remove the heat that is acquired during compression. So that is done by condensation, and then we have expansion. So this is expansion valve. So this is expansion valve, they expands the refrigerant, and then we have evaporation. Evaporation is the last stage. So this is the evaporator, and heat it takes in. So here these are the four processes happening in cyclic manner, and heat in here and heat out here. And this is the evaporation is the refrigeration space where the heat in is taking place, and the heat out is taking place in the uh, condenser element in the refrigeration system. So this is a simple refrigeration system. Advantages and disadvantages of vapor compression refrigeration system over air refrigeration system. Advantages: it has smaller size for the given capacity of refrigeration. It is in compact, size is compact. When you compare air refrigeration system, it has less running cost. It can be employed over a large range of temperatures. The coefficient of performance is quite high. Disadvantages are: the initial cost is high, the prevention of leakage of the refrigerant is the major problem in vapor compression system. So mechanism of a simple vapor compression refrigeration system, and in last diagram I have shown you the overview of the compression system, vapor compression system. So here I will show you the elaborated diagram, and this is the diagram. You can see here, this is the compressor, this is the compressor. Now this is the evaporator, this is the insulated space. So here this is the refrigerated space. From here the heat is removed, and from low pressure side of the compressor, and here it takes the refrigerant at a higher pressure. So it is measured using a pressure gauge, and a high pressure vapor is circulated through condenser. So this condenser removes the heat, high pressure liquid vapor mixer, and this is the area where the heat is removed and refrigerant becomes almost liquid. the refrigerant becomes a liquid, and here that is received by receiver. And this is the high pressure liquid. So we have expansion valve of refrigerant control valve, and this is the expansion valve or refrigerant control valve, and this is responsible to allow the liquid refrigerant to the refrigeration space. So this low pressure liquid vapor mixer is going through as a in the pipes inside the pipes and through evaporator, and it takes the heat. It takes the heat from the substances from the refrigeration space, and now it comes to the compressor again with low pressure, and now this turns out into the gaseous form or whatever form the refrigerant is in. So that is the compressor, and this compressor is a rotary type compressor is used here, and this is a simple block diagram with which you can see all four processes happening. The first process is compression, and then the condensation, and then expansion and evaporation. So these are the four steps are happening here, students. Mechanism of a simple vapor compression refrigeration system. To explain that previous diagram, components of simple vapor compression refrigeration system are compressor, a low pressure and low temperature vapor refrigerant from the evaporator is drawn into the compressor through the inlet or suction valve. Inside the compressor, the refrigerant is compressed to a high pressure and temperature. This high pressure, high temperature vapor refrigerant is then discharged into the condenser through the delivery or discharge valve. So the condenser consists of coils of pipe where the high pressure, high temperature vapor refrigerant is cooled and condensed. So here during condensation process, the whatever form it is in, that turns out into liquid. So that is the condenser function. The refrigerant releases its latent heat to the surrounding condensing medium, usually air or water. So here it may be turning out into usually the latent heat is released in the condenser. Brine is used as it has a very low freezing temperature. So brine is nothing but the very high concentrated liquid. It may be composed of sodium or it may be some other substance also, but it should be essentially high concentrated fluid. So next one is receiver. The condensed liquid refrigerant from condenser is stored in a vessel known as the receiver. It is the receiver. The refrigerant is then supplied to the evaporator through the expansion valve or refrigerant control valve. So expansion valve, it is a type of throttle valve or refrigerant control valve. So these are all the names. You can use any of these names. No problem, students. The expansion valve controls the flow of liquid refrigerant from high pressure side to the low pressure side. So that is the expansion valve function. It actually controls the flow of liquid refrigerant from high pressure side to low pressure side, and it allows the liquid refrigerant to expand, reducing its pressure and temperature before entering the evaporation. Some of the liquid refrigerant evaporates as it passes through the expansion valve. However, the greater portion is vaporized inside the evaporator due to heat absorbed. Then we have the evaporator. So evaporator is the last component in the uh, vapor compression refrigeration system. The evaporator consists of coils of pipe where the liquid vapor refrigerant undergoes evaporation at low pressure and temperature. It is actually made up of a coil. Coils. It consists of coils of pipes which the liquid vapor refrigerant undergoes evaporation at low pressure and temperature. During evaporation, the liquid refrigerant absorbs latent heat from the surrounding medium, such as air, water, or brine, and turns into vapor. So that again, the liquid refrigerant is turning into vapor. It is getting the phase change. This process cools the surrounding area, producing the refrigeration effect. So that is this is the principle, simple principle of evaporator. And the pressure conditions in vapor compression refrigeration systems are, the system has two different pressure conditions. One is high pressure side, and it includes compressor discharge, condenser, receiver, and expansion valve inlets. And next one is low pressure side. It includes evaporator expansion valve outlets and compressor suction line from the evaporator to suction valve A. So these are the two sides, that is high pressure side as well as low pressure side. So types of vapor compression cycles. Here there are different types, and whatever component is changed, or whatever working parameter of the component changes, there will be effect on the vapor compression refrigeration system, and they can be classified in under different headings. I will show you that. The vapor compression cycle consists of the fundamental processes of compression, condensation, throttling, and evaporation. Throttling is nothing but expansion. And to improve the coefficient of performance, that is COP, scientists have explored different cycle variations. And these variations are by changing the working parameter. It can be anything, and there are many working parameters. Accordingly, we can classify the system. Depending, suppose if we consider the superheating of refrigerant or subcooling of refrigerant, and it will be a type of refrigeration system. The important types of vapor compression cycle, it is nothing but it is purely classified based on the change in or deviation, or what you call changing the working parameter. We have these types. One is cycle with dry saturated vapor after compression. Next one is cycle with wet vapor after compression. So here the dry saturated vapor after compression, and wet vapor after compression. So after compression. So then cycle with superheated vapor after compression. Cycle with superheated vapor before compression. Cycle with undercooling or subcooling of refrigerant. So these are the types. These are the five types, and here you can see the parameter, the refrigerant is either made into dry saturated vapor, wet vapor, or superheated, superheated vapor before compression or after compression, and undercooling or subcooling of refrigerant. So these are the working parameters. We are slightly deviate or slightly changing the working parameter, and we are getting these types of refrigeration systems, and each one has its own advantages and disadvantages. Most of these types we are going to discuss in this unit itself, and these variations help in enhancing efficiency, performance, and stability of the refrigeration systems, and these are the advantages we get by changing the working parameter, like in these five types. And this is the introduction about vapor compression refrigeration system, students. In next session, we are going to start the yet another topic that will be very interesting, and where we are going to see two types of diagrams. One is pH and TS diagrams. I will explain how to use those two diagrams, and you are supposed to refer those two diagrams in terms of charts during your examination also. So that will be very important class. All of you should understand how to use those two charts. And then the reference books are, we have these simple books, as usual, CP Arora, and we have RK Rajput. These two are textbooks. You can refer this. Definitely, I can give you the copies of these books. And reference books, we have Ashray Handbook and other books. In all these books, I prefer Kurmi. It is really a simple book to understand this refrigeration systems. And then we have online, that is web content. Web content, you can refer these two sources. NPTEL is the very best source. You can rely on this, and you can definitely learn something out of it. And then we stop here. We will meet in next session, students. Thank you. Thank you very much.